Hello everyone and welcome to my channel, Furner on Security. In this video I'm going to show you how to solve a web exploitation CTF challenge from picoCTF 2021. The challenge is called Some Assembly Required 1. I've summarized the most important information about the challenge on this slide. The task is to capture the flag. You'll also find the link to the challenge in the video description below. Before jumping into the challenge, I want to talk briefly about inspecting a web application. To inspect the web application means to examine its source code. This includes the following components: HTML, or hypertext markup language. This is the standard markup language for documents designed to be displayed in a web browser. HTML describes the structure of a web page by using HTML elements. CSS, or cascading style sheets. CSS is used to describe the presentation of a document written in HTML. CSS controls, for example, layout, colors, and fonts. JavaScript. JavaScript makes a web application interactive. When the user, for example, clicks a button in the application, a JavaScript function is triggered and changes what is displayed on the screen. WebAssembly. WebAssembly is a low-level binary format that allows near-native performance for web applications written in various languages. Web browsers have built-in inspection tools which can be used to inspect the web application. Apart from just inspecting the application, the source code can also be modified with the inspection tool. The changes are shown live inside the browser window. An example could be to do a CSS change to alter the color of an element. Inspecting a web application can help identify potential bugs. It can also help web professionals check, for example, functionality, usability, and accessibility of the web application. For your reference, I'll put a link to Mozilla's documentation explaining the Firefox Page Inspector in the video description. Let's jump into the application. I click the link to start the application. We see the application here where we are supposed to enter a flag and submit it for testing. I'll open the developer tools. I'll reload the application. Let's start by inspecting the HTML page. As we can see, it's a very simple HTML page. We have a link to a JavaScript file, and then we have the body of the HTML page, which is basically just a super simple submission form. Let's look at the scripts. Here we have the full script. It looks like obfuscated JavaScript. So let's talk about the obfuscation of JavaScript before we move on with the challenge. JavaScript obfuscation is a technique that deliberately obfuscates the source code of a JavaScript file, which makes it difficult for humans to understand. A computer can still understand the code and can execute it. The main purpose of JavaScript obfuscation is to protect the code from being stolen, copied, modified, or reverse engineered by unauthorized parties. This can be useful for various reasons, such as protecting intellectual property and business logic, preventing cheating and tampering in online games, hiding sensitive data, enhancing security, and preventing attacks, reducing file size, and improving performance. However, JavaScript obfuscation is not a perfect solution, and it has some limitations and drawbacks, such as it can be bypassed or deobfuscated by skilled hackers or tools. It can make debugging and maintenance harder. There are many tools and methods to obfuscate JavaScript code, but they generally involve a series of transformations, such as renaming variables, functions, and arguments to meaningless names, removing comments, whitespace, and formatting, replacing strings, numbers, and operators with complex expressions, adding dead code, control flow flattening, or self-defending mechanisms. To demonstrate how JavaScript obfuscation works, let's take a simple example. Suppose we have a JavaScript file that contains the following code. We have a function named sayHello, which take a parameter name, and then console logs hello followed by the name. Then we call this function with the username. So let's execute this. Hello, Funer. This code is very easy to read and understand, but if we use an online tool like obfuscator.io to obfuscate it, we get something completely different. So let's try that out. I'll copy paste the code we just used into this box here, and I'll click obfuscate. Here you see something that is very, very difficult to understand. Let's copy paste this code and put it into the console. As we can see, we get the same result here as for the more simple and understandable code. But trying to understand this code is quite challenging. We can see that the obfuscator has renamed the function and argument names to random hexadecimal strings, replaced the strings and numbers with complex expressions using an array of values, and removed any comments or formatting. This code still works exactly as before, but it is much more difficult to copy or modify. JavaScript deobfuscation is a technique that reverses the obfuscation of JavaScript code. It is somewhat similar to decryption, but it does not require a password or a key. It only requires some tools and skills to analyze the code and restore something that is more similar to its original form. The main purpose of JavaScript deobfuscation is to understand, modify, or reuse the code that has been obfuscated by someone else. This can be useful for various reasons, such as auditing or testing the security and functionality of the code, finding bugs or errors in the code, learning from the code or improving it, extracting sensitive data from the code, detecting malicious or harmful code. However, JavaScript deobfuscation is not a trivial task and it has some challenges, such as that it can be time-consuming or impossible depending on the level of obfuscation, that it can violate the intellectual property or privacy of the original author. There are many tools and methods to deobfuscate JavaScript code, but they generally involve a series of steps, such as identifying the type and method of obfuscation used in the code, formatting and beautifying the code to make it more readable, renaming variables, functions, and arguments to meaningful names, replacing strings, numbers, and operators with simple expressions, removing dead code, control flow flattening, or self-defending mechanisms, decoding or decompressing the code with base64 or other algorithms. To demonstrate how JavaScript deobfuscation works, let's continue working on our previous simple example. As we already discussed earlier, this code is very hard to read and understand. It has renamed the function and argument names to random hexadecimal strings, replaced the strings and numbers with complex expressions using an array of values, and removed any comments or formatting. We can now use an online tool like deobfuscate.io to deobfuscate the code again. Let's see how that looks. Let's copy the obfuscated code and put it into this deobfuscator. We have some configurations down below. I'm going to check the renaming of hex identifiers as well. So let's deobfuscate. As we can see here, we're nowhere near the original code we have, but this still looks a bit more easy to understand than the completely obfuscated code. The code should still work exactly as before. So let's try that out. Let's copy this code and put it into the console again. As we can see here, we get the same results as we did in the two earlier versions of this code. And here we can at least try to figure out what's going on, even though it's still very convoluted. So we at least see here that we have the say hello function, which we call, and we supply it with some value. And we can also see that something is logged to the console down here. Let's now try to deobfuscate JavaScript file that we found in our challenge. So let's select this and copy it and paste it into the deobfuscator tool. Okay, so here we have the full code. I'm going to copy it and put it into the console to make it more easy to read. We have an array up here where we see some interesting information. It looks like this code is going to check if the flag is correct or incorrect. The rest of the code is rather difficult to understand, but we can see down here that we do a fetch and await some WebAssembly call. So this JavaScript code seems to be interacting with a WebAssembly binary. The next step now would be to try to find the WebAssembly file and see if we can get something more out of that one. But before we do that, I want to briefly introduce you to WebAssembly. WebAssembly, or WASM for short, is a technology that allows you to run programs written in different languages in the web browser. It is not a programming language itself, but rather a binary format that can be compiled from languages like C, C++, or Rust. WebAssembly programs are very fast and compact. They can interact with JavaScript and other web technologies. WebAssembly is becoming more and more popular on the web thanks to its near-native performance. Some of the use cases for WebAssembly are gaming. WebAssembly can enhance gaming performance by providing access to hardware resources and near-native speed, enabling the creation of sophisticated and high-quality games that operate within the browser. Multimedia. WebAssembly can enable fast and efficient processing of audio and video data, such as encoding, decoding, filtering, editing, etc. High-performance computing. WebAssembly can enable complex and intensive computations on the web, such as machine learning, cryptography, image recognition, etc. Internet of Things. WebAssembly can enable portable and secure code execution on IoT devices, such as sensors, smart home appliances, etc. Blockchain. WebAssembly can enable smart contracts and decentralized applications on blockchain platforms, such as Ethereum, Polkadot, etc. Application portability. WebAssembly can enable existing applications written in different languages to run on the web browser without requiring installation or plugins. Let's go back into our application and try to have a look at the WebAssembly file. The file after the JavaScript file looks like it's some sort of binary. Here we have the payload. This to me looks like it's been base 64 encoded. So before moving on with the challenge, I'll briefly talk about base 64 and encoding and decoding base 64. Base 64 is a way of representing binary data, such as images, audio, or text using only 64 characters that are common to most encoding schemes, such as ASCII or UTF-8. These characters are the uppercase and lowercase letters A to Z, the digits 0 to 9, and the symbols plus and slash. The equal sign is also used as a padding character at the end of the encoded string. The main purpose of base64 encoding is to make binary data safe and easy to transmit over channels that only support text, such as email, URLs, or JSON. For example, if you want to run a WebAssembly module in a web browser, you can't just load the raw bytes of the module because they may contain characters that are not valid or have special meanings in JavaScript or HTML. Instead, you can base64 encode the module bytes and embed them as a text string in a JavaScript file, which can then be decoded by the browser to get back the original module. I'll now introduce you to a tool which can help us easily base64 encode and decode data. Have you ever wanted to do some cool cyber stuff with your data, like encrypting, decoding, hashing, or compressing it, but you didn't know how to use the right tools or algorithms? I'm about to show you a web app that can help you with that. It's called CyberChef, and it's the Cyber Swiss Army knife. CyberChef is a web app that lets you perform all kinds of operations on your data within your browser. You can simply drag and drop your data into the app and then choose from a list of operations to apply to it. You can also chain multiple operations together to create complex recipes that transform your data in amazing ways. Some of the operations you can do with CyberChef are simple encoding and decoding, like XOR and base64. More complex encryption and decryption, like AES, DES, and Blowfish. Creating binary and hex dumps of your data. Compressing and decompressing your data with algorithms like gzip, zip, and bzip2. Calculating hashes and checksums of your data with algorithms like MD5, SHA-1, and CRC32. Parsing network data like IP version 6 and X.509 certificates. Changing character encodings of your data like UTF-8, ASCII, and base64. CyberChef is designed to be easy to use for both technical and non-technical users. You don't need to install anything or have any programming skills to use it. You just need a web browser and some data to play with. You'll find a link to the GitHub repo in the video description. Let's jump back into the CTF challenge and see how CyberChef can help us find the flag. Here we have the GitHub repo of CyberChef. As you can see here, we have a link to an online version of CyberChef. Let's go back to our application and copy the response payload for the WebAssembly binary. Paste it into input, and then we add the from base64 recipe. Here we can see the output, and at the end we have actually found the flag. So let's copy that and go back to the challenge. Let's try it out in the application, and that's the correct flag. Let us submit this flag. Hooray! We earned 70 points and solved the challenge. The techniques that we used to retrieve the flag are called the Web Application Inspection, JavaScript, deobfuscation, and base64 decoding. Now that we've solved the challenge, let's summarize the main lessons learned. To inspect a web application means to examine its source code, which includes HTML, CSS, JavaScript, and WebAssembly. HTML is the standard markup language for documents designed to be displayed in a web browser and describes the structure of a web page using HTML elements. CSS is used to describe the presentation of an HTML document and controls layout, colors, and fonts. JavaScript makes a web application interactive by triggering functions that change what is displayed on the screen when the user interacts with it. Web Assembly is a low-level binary format that allows near-native performance for web applications written in various languages. Web browsers have built-in inspection tools that can be used to inspect and modify the source code of a web application. Inspecting a web application can help identify potential bugs. JavaScript obfuscation is a technique that makes the code hard to understand for humans, but not for computers. It is used to protect the code from unauthorized copying, modification, or reverse engineering. JavaScript deobfuscation is a technique that reverses the obfuscation and restores the code to a more readable form. It is used to analyze, modify, or reuse the code that has been obfuscated by someone else. Both techniques involve various transformations, such as renaming, replacing, removing, adding, encoding, or decoding parts of the code. Base64 is a technique that converts binary data into text using 64 characters. It is used to transmit binary data over text-only channels, such as email or URLs. CyberChef is a web app that can base64 encode or decode data, as well as perform many other operations, such as encryption, compression, hashing, and parsing. It is a simple and powerful tool that works in the browser and does not require installation or programming skills. Learning to use the inspection tools of your web browser, JavaScript, deobfuscators, and CyberChef are skills that you need to know if you want to get into web exploitation. Of course, there's much more to learn and practice in this field, but I hope this walkthrough has given you some useful insights and tips on how to get started. If you have any questions or feedback, please feel free to add a comment below. And don't forget to like and subscribe if you enjoyed this video. Stay tuned for more videos on CTFs and other security-related topics. Thanks for watching, and I'll see you next time.